Hello, good afternoon, good morning, good evening, whatever time zone you are coming from, you are highly welcome. Welcome back to my channel, and this is for the love of chemistry. Yes, whatever channels you're coming from, YouTube, Facebook, TikTok, Instagram, you are highly welcome. This is your one and only channel where chemistry is made fun. You are welcome. All right, today we are going to introduce second term SS1 week 1, and the topic is kinetic theory of matter. The topic today is what? Kinetic theory of matter. And the kinetic theory of matter, as we know, when you hear kinetic, what comes to your mind is movement. So before we even talk about the kinetic theory of matter, a reminder of what we said last week when we were introducing chemistry. We said that matter is anything that has mass and occupies space, which means that everything around us is matter. Alright, so if matter is anything that has mass and occupies space, it means that matter is both solid, liquid, or gas. Because what we have is either that thing is a solid, or it's a liquid, or it's a gas. And in chemistry, we call that states of matter. So let's look at the states of matter. Before we can discuss kinetic theory of matter, we need to discuss the states of matter. And matter exists in three states. Three states. And those states are the solid states, the liquid states, and the gaseous states. Solid, liquid, and gaseous states. So the kinetic theory of matter, as we already know that matter is made up of tiny particles, and these tiny particles are the atoms, the molecules, and the ions. And the kinetic theory of matter postulates that these tiny particles are continually moving and possess kinetic energy. Remember I said that when you hear of kinetic, you talk about movement. So the kinetic theory of matter postulates that these particles of matter are constantly moving, therefore they do what? They possess kinetic energy. So the kinetic theory of matter states that the particles of matter are continually moving. And because they are continually moving, they possess kinetic energy. That is all we are talking about in the kinetic theory of matter. They possess kinetic energy. This solid, liquid, and gas, they are continually moving, and therefore they possess kinetic energy. That's what we are talking about in kinetic theory of matter. Remember I said once you hear kinetics, it's talking about what? Movement. So it's simply telling us the fact that matter actually moves. Now let's look at the three states of matter to see what kind of movements they undergo. What are the movements? What are the movements that they undergo? So let's look at solid a bit. Before we talk about the movement, let's just look at the solid a bit. What is solid state? What is solid state? And when you are talking about solid, you of course, this is solid, this is solid, this is solid. Everything you see here mostly are solids. And these solids are formed by various chemical combinations. Of course, in your first term, you must have solid chemical combinations. You have electrovalent combination in which there is a metal and a non-metal coming together to give you a solid. You have covalent combination whereby two non-metals come together, and you have your metallic bonding and all that. all these things result in either a solid or liquid or a gas, depending on the kind of bonding. So when it comes to the solid state, we'll have the, we have the electrovalent bond, we have the covalent bond, we have the metallic bond, or we have even the very weak van der Waals forces. So the level of the strength of the bond determines the strength of the solid. So if the bond holding the particles of the solid together is very strong, that means that solid will be very strong. And as we know, the particles of solid are closely packed together. When you look at this, you will not even say, okay, this is the bond that made up this one. You can't even see what actually makes it up. You're just seeing something that is already together. But this thing consists of tiny particles that come together to make it up. And they are held together by a strong bond. That is why it appears as a unit. So you realize that solids are very closely packed together. So that also affects their kinetic energy. The situation whereby solids are so closely packed that they can't just move on their own. We're not talking about movements as a result of maybe I collected this and I kept it here. That's not what I mean. We're talking about movement on its own, as it's here like this. Is it moving on its own? Of course, if you leave this thing here for 1,000 years and nobody pushed it, it will stay exactly where you let it, because solids only undergo two types of movements, and they are vibration, so they vibrate, they rotate, but they do not translate. They vibrate, they rotate, but they do not translate. So the translation is like moving from this point to this point. That's translation. So they, as it is here, you will not even see the vibration. That's it. But the molecules, the tiny particles that make up this thing are vibrating. They are rotating, but they cannot translate. They do not translate. They do not translate. And this is because the force, the intramolecular forces holding the particles of the solid together is very strong. Therefore, it does not translate. And also, there are other properties of a solid that we need to take into cognizance. For instance, their volume, because they are closely packed and they are like they don't move anyhow, they have a fixed volume. You know, all these properties usually is determined by the type of force holding them together. Because because the force is very strong, they don't move anyhow. They just vibrate and they rotate and they stay in the same point. The rotation is around the same axis. That means they will have a fixed shape. The shape of this thing cannot just wake up any day and begin to change, unless, of course, you do something to it. But on its own, the shape remains the same because the forces holding this particle together is very strong. So they have fixed shape. Solids have fixed shape. They also have fixed volume. The volume of this cannot change because of course, the same reason because the force holding them together is very strong. So it cannot, the volume is the same, is this, it doesn't change. So they have fixed shape, fixed volume, and it's very difficult to compress it. It is very difficult to compress this thing. Almost incompressible, unless, of course, you have to apply a force that is far higher than the force of attraction holding these particles together. That's where you can compress it. But it's very hard to compress. It's difficult to compress. Not impossible, of course, but it's difficult to compress. So another property is that it is difficult to compress. difficult to compress. So in summary, for the solid has what? Very strong intramolecular forces holding the particles of a solid together. When we talk about intramolecular force, it is the force holding the particles that make up a solid. Intramolecular, within the same molecule, holding them together. And these particles, we know they are made up of either atoms, ions, or molecules. So I'm using this my duster as an example because this is made up of tiny particles, and these tiny particles become one because something, which is a force, bound them together. So because the force holding it together is very strong, it does not move anyhow. That's why it vibrates in the same place. It rotates, but it does not translate. So solid vibrates, rotates, does not translate. So you can say solid VR, solid vibrates, rotates, does not translate. And then when you come to other properties, it has fixed shape, fixed volume, and then when it comes to compression, very difficult to compress. So that's the summary for our solid. All right, now let's go to the liquid. So you look at the particles of the liquid, you see that the particles of the liquid are slightly further apart than those of the solid. And they have more kinetic energy than those of the solid because they are no longer held in a fixed position. And the movements they make, they can vibrate, they can rotate, and they can also translate. But their translation is quite limited. They vibrate, they rotate, and they also translate. But the translation is limited to, for instance, when you pour water here, the water will definitely move from where you pour it and spread out as much as it can. But of course, there is no way the water you poured here will reach past this window or begin to go far. But it has at least moved from this point to another point. Unlike the solid, that when you keep it here, it cannot move on its own from this point to another point. So you see that the particles of the liquid are further apart than that of the solid. And that is because the intramolecular force of attraction, the cohesive force, that's cohesion, force of cohesion, that's what keeps them together, is far less than that of the solid. So you see that the force of attraction between a solid and a liquid determines the movement of the solid or the liquid. Does it make sense? I'm trying to say that whatever is holding this particle together will decide how much they will move. If somebody is hugging you 360, like holding you like this, it will be very difficult for you to move freely. If someone is hugging you by the side, it's easier for you to move more compared to someone that is being held 360. Then if someone is just holding you by the hand, you can literally shake every part of your body, maybe except for the hand, or you can even take off from that hand and move. Now let's use this to explain the solid, liquid, and the gaseous state in terms of their intramolecular forces. So the solid is like somebody is hugging you like this. You can't move from here to here. You are just rotating within that place. You are vibrating within that place. Then as for the liquid, is like person is holding you like this. You can move your leg this way. Have you seen? You could make kind of translatory movement, but you can't move so far. But then when it comes to the gaseous state, okay, we are going to get there. But when it comes to the gaseous state, let's say the force holding them together is like a handshake. You have a handshake. You can move and then even separate from the handshake and keep going. That is exactly how this is a perfect example of how this works. The solid state, the person is giving you 360 and holding you like this. You can only vibrate, you can only rotate. When it comes to the liquid, you are The person is hugging you from the side, but you are free to move a bit. But then when it comes to the gas, you are kind of having a handshake that you can easily break off from. That's exactly a good analogy for that. So the liquid vibrates, the liquid rotates, and the liquid translates. So when it comes to the shape, the liquid, of course, does not have a fixed shape. It only takes the shape of the container. So no fixed shape. You don't even need to cramp this. You know water. Does water have shape? Any container you put it inside, that's the shape of the water. It does not have shape. Your fuel, does it have shape? All the liquid fuels that you use, they have shape. They only take the shape of their container. So you don't even need to cram this one. Liquid does not have shape. Solid, of course, this thing has shape. So you don't need to cram it. And then the volume, of course, it has a fixed volume. It has a fixed volume. And then it is hard to compress as well. It has fixed volume. It has a fixed volume and it's hard to compress. It is hard to compress. It is hard to compress. That's for the liquid. Okay, so let's summarize the liquid. The liquid, it vibrates, it rotates, it translates. Vibrates, rotates, translates. No fixed shape, fixed volume, hard to compress. I think that's simple enough. The properties of a liquid, the movement it does, vibrates, rotates, and then translates. The shape, no fixed shape. You don't even need to cram it. Every liquid has no shape. Liquid, just remember shapeless amoeba, you get it. Every liquid has no shape. And then volume, the volume is fixed and it is hard to compress. Now the gaseous state. The gaseous state. The gaseous state, of course, that's the one that is flying everywhere. Right now, air is blowing you. You can't even see the air, but you can feel it. Because they are busy moving. When you come under a tree, you feel a rush of wind, of breeze. What is happening? The air is blowing, is moving. Then you can see the wind. The wind is vibrating and moving and moving. So the gaseous state undergoes every form of movement you can think of. Vibrates, rotates, translates, it does every type of movement, zigzag movement, whatever movement that you can think of, and it moves with great speed. It moves with great speed. It moves with great speed, and the forces holding them together are very negligible. What do you mean by negligible? It's like, just like I say, a handshake. That's the way they shake. There is, you shake someone like this, and you can very easily separate from that person. So there is really nothing much holding you and the person together. So the force of attraction between the molecules or particles of a gas is very, very negligible. That is why they can move with great speed. So you see that the kinetic theory explains the properties of each state of matter, whether it is solid, the liquid, or the gaseous. Because when it's solid, the kinetic theory is low, therefore it will have a fixed shape, a fixed volume. When it's liquid, the kinetic energy is not as low as the solid, but not as much as the gas. Therefore, it will vibrate, it will rotate, but it will not have a fixed shape, but it will have a fixed volume. Then when it comes to the gas, it has neither fixed volume nor fixed shape. Because wherever it comes, it spreads out. So it kind of occupies the volume of the container. The size of the volume of the gas is the volume of the container. But when you actually now compress the gas to see the actual volume of the gas, you see that it is very small compared to how it has spread itself. So it has no fixed shape, no fixed volume. It has no fixed shape, it has no fixed volume. So you see that the movements of the states determine whether they will have shape or they will have volume. The solid has both shape and volume, and it's hard to compress. The liquid has volume, but it has no shape. It takes the shape of the container. While the gas has no shape, it has no volume. It takes the volume of the container, it takes the shape of the container. So it has no shape, no volume. And it is very easy to compress. Why? Because they are so far apart. You just kind of just bring them together. And it's very easy because there are the distance, the intramolecular distance is very high. So by compressing, you are trying to bring them closely together, and it's easier, far easier, because they are very far apart. How do I say it now? For instance, like I described with the hog. If I try to bring this person closer to me, I'll usually be killing the person. The person I'm holding with a side hug, if I try to bring the person, yeah, I still have some space to bring them in. But when the person it is just a handshake, and I want to bring them in, there are so many things I can do. I can do side hug. I can hug. You see, the more I'm bringing them together, the more I'm compressing the distance between us to create a bond. Is it making sense? So it's the same with the solid, liquid, and gaseous states. The further apart their molecules are, the more easily compressed they can be, because compression is simply bringing the molecules more together. Am I making sense? Okay, so that is for the properties of solid, liquid, and gas. So in summary, let's make it a summary so that you can very easily remember it. Let's summarize it. So we have the properties, solid, liquid, and gas. So we have movements. This one vibrates, rotates, does not, let me just idea, does not translate. Okay, and then movement for the liquid vibrates, rotates, translates. And movement for the gas vibrates, rotates, translates. And any other movement that you can think of. Then the kinetic energy. Let's look at the kinetic energy. Very low. This one is more than the solid. Very high kinetic energy. So intermolecular force, is it intramolecular forces, or you can say forces of cohesion, cohesive forces, intramolecular forces or forces of cohesion, very strong. This one, less than the solid, and this one very negligible. Very negligible. I think I want to use up here. Very negligible. So let's just so are you seeing we are trying to group it to make it very easy to remember. Very easy to remember. So we have the properties, solid, liquid, and gas. Okay, so all right, the density, let's look at the density. This is very dense, and density is mass over volume. Very dense, less dense, the least dense, density, very dense, least dense. So the volume, you already know this, fixed volume. This one, fixed volume still. And this one, no fixed volume. Then the shape, fixed shape. No fixed shape. And this one, of course, no fixed shape. Then the compressibility, compression. You can say hard to compress or incompressible. Incompressible. Why this is compressible, easily compressible. Okay, I think we've touched all the properties. Okay. All right, so that's it, right? The density, solid is very dense. The mass over the volume, very dense. The liquid, less dense, while the solid is least dense. When you talk about density, you're looking at the weight, how weighty it is. Then the volume, of course, the space it occupies. It has a fixed volume, it occupies only this fixed place. Then the liquid has a fixed volume, and then the gas has no fixed volume. The shape, the solid has fixed shape, the liquid has no fixed shape, and the gas has no fixed shape. Compression, this is incompressible, incompressible. The liquid is incompressible, while the gas is compressible. Movement vibrates, rotates, does not translate. Liquid vibrates, rotates, translates. Gas vibrates, rotates, translates. And then if we look at this movement, from here to here, that's from gas to solid, kinetic energy reduces. And from solid to gas, kinetic energy increases. Here, kinetic energy decreases. As you move in this direction, you are moving from gas to solid. Kinetic energy decreases. But if you are moving from solid to gas, kinetic energy increases. Am I making sense? Alright. So that is the comparison of the solid, liquid, and the gaseous state. Okay, so what next we're going to do is change of states. Change of states. Change of states. How does that happen? Change of states. Change of states. Okay, we already know that we have solid, liquid, and gaseous states. Now let's see how this, what's it called? How the states, the change of states happens. What are the terms when we move from this to this and from that to that? What are the terms? What are the terms? Okay, so we have when a solid moves from solid and becomes liquid, we call it melting. And when a liquid moves from liquid to become solid, we call it freezing or solidification. Freezing or solidification. And then when a liquid moves from liquid to become a gas, we'll call it evaporation or vaporization. Or vaporization. We call it evaporation or vaporization. And when when a solid moves from being a solid